title of this session is intentionally a little provocative, and if I could get my guys in the back of the room to put up my title slide here. We're calling this session Broadband is Not Enough. So for more than 2 decades, those of us working in the broadband industry have been focused on an enormously important challenge. How do we make sure that every home, business, school, farm, healthcare facility, and community has access to affordable high-speed internet? That work is not finished, and it remains absolutely essential. But as artificial intelligence begins to reshape virtually every sector of the economy, I think we need to broaden the way we think about connectivity. Because connecting someone to broadband answers just one question: can they get on the internet? That does not necessarily answer another increasingly important question: once they get onto the internet, where does their traffic actually go? And that distinction is becoming much more important and relevant. You can deliver a gigabit connection to a home, a business, a university, a factory, but if the network serving the customer has to carry traffic hundreds of miles to another metropolitan area before it can efficiently reach another network, a cloud platform, or an AI compute resource, then the performance of that connection is being determined by infrastructure that most users never actually see. There is physical distance, there is routing, there is congestion and packet loss, there is the availability or lack of availability of multiple network paths, and ultimately, there's the physics of light. One way I think about it is that we have spent billions of dollars in this country building better roads to homes and businesses in America, but in many parts of the country, we haven't built out the actual traffic interchanges. That is the problem we are trying to address at IXP.US. So IXP.US is a joint venture between Connected Nation, my employer, and Newby Ventures, and I'm going to introduce Hunter Newby in just a moment, with a mission to develop neutral network interconnection facilities in regional markets across the country. We have identified 135 target communities in 47 states where this type of infrastructure is literally missing today. At the simplest level, these facilities are places where networks meet. Local and regional ISPs can come in, long-haul and middle-mile networks can come in, education networks can come in, mobile network operators can come in, cloud and content networks can come in, and increasingly, AI compute can be located directly adjacent to all of those networks. Instead of forcing all of that traffic to travel to a handful of major carrier hotels in major metro areas, we want to create neutral regional marketplaces where those networks can interconnect much closer to the communities they serve. Our first facility, the alpha site for this national model, is at Wichita State University in Kansas. This facility is directly across from Wichita State's Innovation Campus and is designed to become the first neutral network interconnection facility serving the Wichita market and actually the broader Kansas region. And this is no longer a conceptual project. The hardened modules that make up the facility have arrived in Wichita on 3 semi-trailers and have been delivered and hoisted into place. The physical facility is nearing operation, and network operators will begin building into the site here in a couple of weeks. What I particularly like about this project and some of the photos that I'm going to show a little bit later in our discussion is that this facility demystifies the internet. The internet is not a cloud, this amorphous thing that lives up here in the sky. It is buildings. It is fiber, it is conduit, it is manholes, it is the switches and routers, it's power systems, it's backup generators, and most importantly, it is the physical places, the physical buildings, where one network can connect to another network. The Exchange Fabric launching in Wichita will be called Omnexus IX, powered by DKIX, which is one of the largest internet peering platforms in the world. And the intention is to extend that exchange platform to locations everywhere we go all across the United States. But the vision is broader than internet peering alone. The next evolution is to bring compute to the point of network interconnection. So IXP.us and Moonshot, you'll be hearing from them momentarily, represented by my friend Bryan, have announced a model that pairs our carrier-neutral interconnection facilities with modular AI compute infrastructure scaling across the larger footprint across the US. The idea is straightforward. Rather than asking every AI workload to travel to a distant hyperscale data center, we were going to put the appropriate compute resources closer to the networks, the data sources, the institutions, the businesses, and the users that need them. And I think about, as I think about that, it raises an important question around broadband policy for the next decade. What does it mean for a community to truly be connected to the AI economy and the infrastructure that actually runs it? Is it enough to have fiber passing every premises? Or does an AI-ready community also need access to competitive middle-mile transport, to neutral network interconnection, to diverse network paths, to cloud connectivity, to internet exchange capacity, and increasingly compute? I think you can probably guess what my answer to those questions would be. Our objective nationally is to make sure that smaller cities and towns across America do not become last mile connected, but upstream dependent. We want communities to have more choices where traffic goes, more resilience when something fails, better economics for local networks, and much closer access to infrastructure that will power the next generation of applications. That's what we're going to explore today. And I could not ask for three better people to help us do that. So if I could get my three panelists, Hunter, Bryan, and James, to come on stage, I will introduce them individually. So first is Hunter Newby, owner of Newby Ventures and my partner in IXP.us. Hunter has spent his career building the physical infrastructure where networks meet. He is a co-founder, chief strategy officer, and director of a company called TOWARDEX. Which was the company that helped pioneer the carrier-neutral meet-me-room model that became foundational to internet interconnection across the United States. Since TOWARDEX, he has continued developing and investing in neutral interconnection infrastructure across North America. Much of what we're trying to do with IXP.us is to take the very interconnection ecosystem that Hunter helped create in the largest American cities and bring that opportunity to regional communities that have never had it. Hunter, welcome.
Thank you.
Next is Bryan Lubin. On my far left, Bryan is the managing director and of digital and compute infrastructure at Moonshot Energy. Bryan works at the intersection of land, power, capital, and compute, helping AI infrastructure projects from conception through deployment. His work includes AI data centers, GPU infrastructure, modular compute, power-driven site development, and a particular focus on three of the biggest constraints facing AI infrastructure today: power, speed to market, and the ability to scale. Bryan is going to help us connect the networking discussion to the compute side of the equation, which is where this conversation, I think, gets especially interesting. Bryan, welcome. And finally, James Junn is the founder and CEO of TOWARDEX Technologies. James has more than 20 years of experience designing and building internet infrastructure and neutral interconnection systems. In Boston, Massachusetts, he pioneered the large-scale carrier-neutral Meet Me Street underground conduit network connecting the physical interconnection ecosystem that gives network operators greater choice and competition in Boston. He also founded MassIX, the largest carrier and data central neutral internet exchange fabric in New England. TOWARDEX is also an important partner in the IXP.US model, particularly around the diverse physical fiber and conduit infrastructure that allows multiple networks to reach our facilities. James, welcome. All right, let's transition into this discussion, and for that, I'm going to join you here. Come on. So, Hunter, let's start at the highest level. We've spent decades talking about last mile broadband, and many of the people in this room build those last mile networks. Some of the broadband offices in this room are responsible for funding some of those networks. What is the piece of infrastructure that is actually missing after the last mile?
Neutral real estate. Broadband is a word that, I hope no one takes any offense to this. It doesn't mean anything. It's like fiber or data center. It got so many definitions that it's almost meaningless. I spend a lot of time railing against data center as a catch-all phrase for everything, and now the industry has caught up with that and applied NIMBY to it because the industry itself has taken a lot of resources away from people without thinking about them. And we don't build data centers. That's not what I've ever done. I build neutral interconnection facilities, also known as meet me rooms, and they're inside carrier hotels. I've bought a lot of carrier hotels and built a lot of meet me rooms. The problem is that I can't say meet me room in rural America, or they think I'm in the dating business. And I can't say carrier hotel, or they think that we have mattresses and we compete with Marriott and Hilton. So we build internet exchange points, which is actually a real industry term in the internet infrastructure world. The internet exchange point is a physical place. It's like the room or the building where the internet exchange or switch is. So just to put it really succinctly, broadband in the last mile, as Brent was saying, a lot of money in grants for fiber to the home and whatnot, without any regard for a network diagram ever submitted to any broadband grant that's ever been allocated in the US, where that network diagram showed an actual neutral internet exchange in the same state where the money was deployed for the fiber. That's a problem. The internet, the old internet architecture, it doesn't work anymore. Not for inference, not for AI, so.
And as a follow-up to James, from a network engineering standpoint, what actually happens when we force traffic to take those long routes? Where do latency, routing, inefficiency, and resiliency start showing up, especially as we look toward the future?
Sure, absolutely. So initially on day one, you're not going to see the provider that's building the network is not going to see a lot of difference because they're not used to the customers pushing traffic yet. As their customers start using services, whether it be something, Netflix to online gaming or AI, whatever that is. Now, like take for example Wichita, our alpha site. A lot of the traffic there to even get to a regional, enterprise that's local in the city, it will typically get down to Dallas and all the way back, right? So the end users start feeling that over time. What happens over time, it starts becoming cumulative, right? So on day one, the upper tier management at an ISP is not aware of these problems. And then what happens is over time, it turns it into a customer satisfaction issues where, the customers are generally not really happy with the performance, right? There's a lot of open tickets, right? So from a performance perspective, it's not something that you see on day one. It becomes cumulative, and it carries an interest that keeps getting added as more users start using the network.
Thank you, James. So for our next question, I'm actually going to grab my clicker here from the podium, and we're going to talk about what this facility looks like, because we can talk about these things, and they're sort of amorphous things, and I'm a visual guy. I like to see things. I like to see photos, right? I'm sure some of you in the audience are that way. So, Hunter, walk us through how help us make this tangible. A lot of people hear the term Internet Exchange Point and imagine a piece of software or maybe a switch somewhere in a telco closet in the back of a building. But what we build in Wichita is physical infrastructure. So walk us through the anatomy of this facility. And as you're doing that, I'm going to bring up some photos of the facility, which is still under construction, by the way, but we're going to be operational here in a few weeks. And then, James, I'd like you to chime in, too, when we're talking about some of the underground infrastructure that we built to make the facility operational. So, Hunter, would you start?
I will. I just want to say I kind of feel like I'm in like a mega church sermon. This guy right here, he's like a pastor. It's a cross between that and like Phil Donahue or something. This is really professional and interesting. And your voice makes me think I'm like on the radio, or you are. So, yeah, let's bring up the pictures, at least the ones. I'll be able to see it there, right, when we talk. Yeah. So anyway, yeah, the anatomy. Oh, geez. I bought a lot of buildings, a lot of carrier hotels. They happened by accident. They weren't by decree. The FCC didn't say, hey, this office building is going to become the carrier hotel of the city. It happened. After the consent decree and the CLEC boom in the 90s, fiber network operators just started building into buildings. So 910 right here, the Gaslight building. Or 1500 Champa. They both have histories. They weren't mine at any time, but 1102 Grand in Kansas City, Missouri was, and that was an office building, and they were all by mistake. What you're looking at, and right now it's a rendering, so to be honest, you're going to see the actual pictures. The building is there now. This is the first time, and I've done new things from scratch a couple times. I built a long-haul fiber route from Miami to Atlanta and my own ILAs every 60 miles on railroad right-of-way, so I have familiarity with building modular buildings that are really neutral meet points. But this is the first time I've done one where it's decoupled from my own long-haul fiber route. And I also did a neutral cable landing station in New Jersey called NJFX, which is a standalone structure but tied to, obviously, long-haul submarine and terrestrial fiber. But just imagine the meet me room in a carrier hotel. Just pull it out and then just say, what is it physically? And then create it greenfield. So that's never been done. People build data centers, modular edge, whatever. They don't even understand what they're doing. That's about servers mostly and power. That's not what this is or for. We are sort of bending our own rule with Bryan. We'll get into that in a second. And I'll try to get through this as quickly as possible. But yeah, so there you go. This is the parcel that we got from Wichita State University. It's state land. It's a 40-year ground lease, $1 a year, and we got a $5 million grant to build this building. And we, of course, spent over $1 million plus doing manholes with this guy, which wasn't part of the grant. You could see the design here. Again, the anatomy of, there's certain things here that are really important. It's our own land. We control it. We own the building. We own and operate the operating colo business. We own and operate in a separate entity the actual Internet Exchange switch, which that business is called OmNexus, which Brent mentioned. You could see 21st Street there and Fountain Avenue, if you're all familiar with Wichita. 21st Street's a main thoroughfare, basically goes right along Wichita State University. Just to the bottom of this picture, which would be the south, is the X Stadium, the baseball stadium. And you see that we've got on our parcel there 2 zero manholes at the bottom of the south side, and then literally 2 street cuts that go to our 2 vaults that we also interconnected. It's all owned by us. It's all controlled by us. We extended the demarc. There you go. You could see the street cuts there. We extended the demarcation point for the outside plant fiber to meet us, either on the south side or the north side, where we just assign pathways. Nobody has to pull any permits to dig the street and cut. They just have to get to our vault and our serving manholes to the main manholes, which James will talk about in a second. This is crucial. This is a key part of the anatomy of a successful, vibrant, neutral interconnection facility. It is devoid. When you talk to anybody about a modular whatever, modular colo, modular data center, whatever, none of those people are talking about outside plant. They're just talking about the building and how many racks you want in it and maybe some power density stuff. This is purpose-built as a meet-me room. The density of power per rack and cooling is not data center. It is interconnection. And it's proven by how much outside plant work we did that's not the building itself. There's over a mile of 4-inch PVC under the ground in terms of the number of conduits we have that are stacked. And this is just to make thoroughfare possible. And then obviously once you come inside to terminate I don't know if we have a picture of it there. The key elements of the interior. Okay, well, that's the manhole pictures. I'll let James do that. Okay, go back one. Yeah, right there. So this is an overhead of the rendering. Obviously, we could show you this live today, but see the yellow raceway there? That's for jumpers. That's for cross connects, which, by the way, we don't charge any monthly recurring cross connect fees. I never have. I never will, ever. I don't believe in them. I was at 214. I was a carrier once, so I hated local loops, so I don't do that. But you can see the ladder rack configuration in the open racks. It's an A and a B. These are what we call the meet me areas. There's fiber panels, basically. That's it. No active elements. You could take the outside plant cable and terminate it to a panel in one of the open racks or two, or you could go all the way to your cabinet and re-originate what we call home runs from your equipment in there. That's where all the interconnections happen. We inventory and tag every single interconnection. Our people do the cross connects. Nobody else is allowed to touch anybody else's panel. Of course, you could touch your own, but that's it. It's about security. It's about inventory management. That is key to an interconnection facility. If you don't have that, you're not in this business. You're doing something else. You're doing data center or something. And then the way that the rest of the facility is laid out, AB power rooms, we have a little conference room for meetings, a storage area, cabinets, hot aisle containment, that's kind of normal. But those elements are the anatomy of a neutral interconnection facility, and then add to it what James does, which I'll now pass the baton to James to walk through the manholes. Is that good? Did I cover it?
That's very good. Yeah. So James, why do conduit, manholes, multiple points of entry, physical diverse fiber routes into a facility like this, why do they matter? I want to try to bring up some of the photos here.
Yeah, if you could just go to the manhole pictures, let's start there. Yeah, there we go. So, yeah, so before I start, that particular picture was a guy standing there. We were asked by folks back in ITW, is that the meet me room that you're putting there? And we just smirked. No, that's actually a manhole. That's not the main building. But so we have two main, what we call zero manholes. So to Brent's point, when we talk about physical diversity, so physical diversity is interesting to me. For me as a network operator, and I'm sure for many of you in this room, physical diversity is a must for customers, especially for enterprise customers, right? And we all compete on that as one of our added bonus for customers to use our network versus our competitors, right? So physical diversity to me is a baseline requirement for anybody that's in the network business. Now, what we are doing here with the IXP is, physical diversity to us, we have to go above that. That's just a given. So what does diversity really mean for us? So first of all, as you've seen in the diagram, it's already fully diverse coming on the east, west. We have a master plan for additional points of entry to be constructed in the future. Not only are we providing the physical diversity, the most important thing for us is how do we build a scalable system, a scalable handhole, manhole system where we as the neutral operator, infrastructure operator, own and operate it for you on a neutral basis, where everyone and their literally every single carrier, every fiber carrier, ISP, even content provider, whomever that wants to have fiber placed in, they can literally get a license to pull that cable immediately with no construction required. They don't have to, tear up the streets. So it's like, the industry term that a lot of us in the utility parlance say is a dig once. So that's really that model. So when we look at a typical manhole, we build for success, right? We fit it out with introduction side for what we call pathway. So pathway is, in our system, we don't allow tenants to put in their, to pay money to put in their own introduction, nor do we require tenants to do any make-ready work. We do all of that for you. All you have to do is you come in, bring your cable. Your biggest CapEx is a fiber optic cable that you already own. That's it. And then we put it through the system that's already ready. You already got an introduct pathway assignment all the way to the meet me area, to your colo. And you can also do splicing. We have what we call joint bays in the manholes, where instead of everyone throwing their splice cases on the floor and stepping on each other, everybody gets a designated splice case location. That's what we call a joint bay. So it's like we took the concept of co-location down into the manholes. So no more chaos, none of that. So to quickly finalize your question, the true diversity that we're looking for is above and beyond the physical diversity, and that is how do we maximize as many carriers to be able to work together in a controlled, coordinated manner. And that's what this infrastructure is for.
Thank you, James. So I'm going to transition now to a question for Bryan. So Bryan, as we talk about moving from traditional internet infrastructure to AI infrastructure, we're hearing almost every day about enormous hyperscale AI data centers. But the model we're talking about here is a little different than that. So what types of AI workloads actually benefit from distributed compute located close to network interconnection facilities like this? And then why are we about to do, here in our Wichita site, something very different and unique with you?
Thanks, Brent. So I think a lot of everybody now knows in terms of what's actually been advertised, as you've seen now in the markets, in terms of power in general, megawatts to gigawatts. The ability to actually energize, right, has really come into question, and it's something that Hunter and I originally bonded over in regards to how the relationship began. And one of the things that I focused on in terms of, what is the Achilles heel of a lot of these sites, especially when you move into AI, it became the network. And the natural progression, right, of what we've seen from training to large language models to now inference and agentic, to Brent's question, is the value that we're creating. So in order for what NVIDIA calls, physical AI, or the AI grid, that is what they refer to for inference and agentic purpose-built applications. And the way that they talk about it is the time to first token and the value of that token. And the value of that token is generated based upon the latency in which the application is being derived to, which is built for inference and agentic, which is what these sites that we're physically building are going to be purpose-built for. So the value of what that token can be at ultra low latency. So think about APIs right now for your chat, GPT or Claude or what have you. Those are all above 10 milliseconds in terms of latency. Most of them are closer to like 35. If we're building sub 10, right, for actual physical AI, meaning robotics, transportation, what have you, what is the value of that token now, right? What is the market going to be, which is what now the new asset class, right, is being created, in which is where we really believe what we're building here on a nationwide deployment, Wichita being the alpha, is what we're creating.
So I just want to jump in here real quick, and Bryan's the new dimension to this. We met a year and a half ago or so. But Bryan, why don't you tell them what you did, who you are, how you got here, and then a little bit about Moonshot. This is unusual, and it's what's catalyzing what I've always done now for 25, 30 years, and what James has done, and Brent's side of the house with Connected Nation and rural America. It all is coming together with his background. And I want you all to hear it, because it's really interesting.
Thanks, Hunter. So I come from large-scale commercial ground-up construction. Worked for my father. He was a real estate developer turned financier. So I cut my teeth doing large-scale ground-up construction. And watched him rise and fall of '08, originally from San Diego. Now I live in New York. And I went to go work for the big banks for a little over a decade. I'm an underwriter at heart, as Hunter loves it when I say that. But I created underwriting policies and procedures for the big banks for ultra-high net worth lending. So work for the CFPB and OCC through the banks to create the actual policies and compliance that everybody uses today. If you go to Wells Fargo, Morgan Stanley, what have you, those lending criteria were a piece of me. And eventually I sort of became burned out and started looking at opportunities, and someone came to me looking for 200 megawatts of powered land. And I was like, I don't know what a megawatt is, but I'd like real estate, so let's try it out. And quickly did I understand the value, right? And this is back in 2020, and the value of power, right? What does that actually mean? What does actual powered land mean? That definition has become a bit lost, but I think it's finding its way back now in terms of the utilities. Now that officially, I think a couple days ago, they came out and finally said, right, if you want power at large scale, meaning anything above 5 to 10 megawatts, depending on the county and territory that you're in the U.S., you now need a credit backstop from the bank for the entire build, right? And that's just basically, put up or shut up. And that's been from day one. But you have Texas, right? That's now always has been in the eye, right, of power development. That 90%, I think, is never going to be built, most likely. And it always comes down to the numbers, right? what does a megawatt worth of servers mean in terms of capital deployment in debt and equity? What does a megawatt worth of greenfield development from a megawatt from a tier 3 actually value? And most of the people don't know, right? Because how could you? Because it moves almost every day. But right now, if you were to build a 1 megawatt site of fully computed tier 3, B300, liquid cooled, all the bells and whistles of the words that we know, you're pushing close to 70 million right now. By the end of the year, my belief is that the GPU right now, in terms of the value, will be worth roughly $100,000 a GPU. It's substantially close to that already. So you're starting to see this next change or this next wave of who can actually deploy the GPU as you start to see NVIDIA's market share start to take a little bit of a hit because of supply chain. Moonshot Core, the main company that I work for, is a critical infrastructure manufacturer. So they build the medium and low voltage electrical components for TeraWulf, Hut 8, Cypher, Caruso, which has now become, TeraWulf has become Google and FluidStack and what have you. So we're boots on the ground every day in terms of understanding what they call NVIDIA system architecture, or the neo clouds, what you want to call that. At the end of the day, it's a broker, someone that's using someone else's assets, right? The majority of them, except for the top 7, that are going and placing, right, capital towards a asset that they don't own, but saying, here's an off-taker, right, in which the off-taker is stemming from all from NVIDIA, which is why you see NVIDIA included in every single thing. But what do they actually are able to produce? It's physical supply chain, right? You cannot produce gigawatts worth of GPUs in a year. It's physically impossible. Chips, everything else. So I sort of have always sat in that realm of realistic, right? What does a number mean? How does it actually get deployed? And seeing what James and Hunter and Brent have put together, I saw the opportunity of going, how do we actually make this scalable? How do we actually make it real, right? And how do we deliver the next wave of AI for inference and agentic?
In short, every city that we diligenced years ago in the United States that doesn't have a neutral internet exchange point, but a minimum 200,000 people, state land-grant university, more than 100 miles from the next internet exchange, all of that still remains true. They still need a local exchange point to keep traffic local, reduce latency, reduce cost. But the capital to actually fund all that doesn't exist. That's why we went after the grants and got one. I don't like pursuing grants because the uncertainty of actually getting it and then the sort of Damocles over your head about getting it done on time and all these things we can't control. Along comes Bryan and his background, ground-up construction, underwriting, wrote the laws for the banks to use real estate to underwrite loans, credit facilities, and that's what we're doing here. The cash flow to us, as him being a tenant of us, Moonshot Energy, is enough to financially underwrite all of this and solve that local internet exchange point interconnection problem. The rural broadband problem will be solved. That's number one. Then locating the GPUs proximate or directly next to an exchange, and then finally the cherry on top, which is getting the incumbent ISPs, and James alluded to this earlier, Cox. The core router for Cox in Wichita is in Dallas. The whole city of Wichita is served from Dallas every second of the day. 2 people that both have Cox in Wichita sending an email to each other across the street goes to Dallas and back. 6.6 millisecond round trip. Not acceptable. Every city like Wichita, same thing. So now, with Cox, we're building a very big thing, can't talk about it, but they want this architecture that we're doing with them here, with him and me and us, in all these states after their charter merger is done. And then we've got the same relationship architecturally with Lubin. It took a little while, but they're in Arbach and they get it. And now they've presented us with the cities that are on our list where they're the incumbent and they don't have a core router. It's in excess of 30 cities. So we're gonna build it and it's funded. We don't need grants and we're gonna accelerate all this. And it has many other tangential things. It's a whole AI is a military operation. You probably all heard me say that multiple times. I say that a lot. People think it's a business. It's not. And preparedness is key. Readiness is key. And that's what this infrastructure ultimately is and what it becomes. Anyway, I'll shut up.
Well, I like the flower of life scenario that you...
Like the flower of life, okay. We haven't even gotten into agentic yet, but go ahead.
Yeah, well, that's where I'm going next, right? So I do know the story. So looking ahead 5 years from now, agentic AI is dominating how much traffic is moving across the internet ecosystem as we know it. What happens when a regional hub community like a Wichita or a Boise or a Lexington, my hometown, Huntsville, Alabama, Charleston, South Carolina, what happens when this infrastructure doesn't exist in those communities vis-a-vis comparing to the cities that do have it? Economically, what does that mean? And bring agentic AI into that.
So I'll start and get my part out of the way, and then James and Bryan can talk about it from their perspectives. But internet protocol is not the internet. That's number one. Internet protocol is not the internet. Internet protocol over a private layer 2 interconnection is not the internet. It's controlled, it's deterministic routing, you can control quality, you control round trip delay. That's essential. Breaking the brains of ISPs to make them realize that they need core routers in these cities to accept bits that they take to their endpoints in that city. Sub 1 millisecond, time to first token. That's what is worth the most in this, speed, time, latency, not just throughput. And the amount of throughput that's coming on the north-south from these new inference GPUs is unbelievable. I think it's reckless that NVIDIA has put these things out. In the same way they dumped GPUs for training and broke the electrical grid, they are about to break the public internet. So then let's talk about agentic. What's going to happen here? What we're building is this sort of prototype. The engineering package is coming out for a concept that we noodled out called the pod park. It looks like a firehouse, big garage door, and these pods go in it. Bryan's company, Moonshot, makes those pods. They're physical dimensions. They have exact configurations for power and cooling, for PUE, for the density. I don't build that. We would euphemistically call it a pod, and somebody would probably call it a data center. It shows up on a truck. It parks in the parking space in the garage, and we charge rent. That's it. If those GPUs can come in and go out when the truck picks it up and takes it away or whatever, we don't care, we charge rent. Those garages, those pod parks, will tether to and be satellites to what we're building here. That's why we overbuilt the manholes and the conduits, because hundreds of fiber cables can come into that, and that's what's going to happen. The interconnection drives the need and the ability for the agentic GPUs to cluster and connect to each other. And a lot of this conduit thoroughfare access is built for those GPU clusters to connect directly to each other, backplane to backplane. No ISPs, no carriers, no lit service, no even monthly recurring fiber pair, metro. The whole concept is for agentic will go away because that's how much data they need to push between each other with no loss. So what will happen? The economic development that will come as a result of creating these facilities is no different than 150 years ago, a city getting a central office, a telephone CO. It's no different than an airport. It's no different than a train station. It's an intermodal yard. It's a hub where networks meet and connect and commerce happens as a result. Places that don't have it will not be able to achieve the sub 10, sub 5, sub 3, sub 1 millisecond round trip delays. And there are many applications. One of the biggest ones is credit card bank fraud. And the credit card companies are willing to spend a lot of money to be in every one of these facilities so that they can capture from the point of sale terminal or from the phone at the keystroke as the fraud is occurring, that data, and then run AI to see that it's fraud and shut it down. They'll save billions and billions of dollars. So obviously they'd love being our tenant and paying us rent. But this whole ecosystem needs to be assembled in order to make that happen. In the places where it does happen, the economy and growth will flourish. And as one of my friends in the credit card company said, the criminals will soon learn where these places aren't, and they'll go there to base their operations because the banks won't be able to catch them fast enough. That's just one example.
Bryan, James, anything you'd like to add to that?
Yeah, so to add upon Hunter's point, what we're doing here is we're essentially building the new internet, and I'll describe a little bit of what that really means. So we identified and discussed a little bit about the problems of latency and all of that. What happens is when you go to a market like Wichita or whatever, it's going to be a tough conversation for a network engineer to go to their boss or go to their board or investors, what have you, and say, we need to improve our ping time to another ISP that's next door. Because the first question they're going to ask is like, why are we spending capital to connect to a competitor? We don't do that. So you're never going to get these people to agree to work with each other when, number one, they don't like each other to begin with, and then number two, they find out that they're going to spend a lot of money doing that. So what you do is you bring the shopping mall, the airport, to these guys. You create an ecosystem where the AI is coming, the inference is coming. Now, all the enterprises are coming where the mathematics and the economics, the incentives change. You change the incentive structure where for these ISPs, what you're doing is if you build to this IXP, you're getting new customers, you're getting new revenue. You are really seeing this international and regional traffic that you've never seen before that you can sell to and monetize your network. And once everyone's jumping into this bandwagon to make more money, all of a sudden these latency problems become an easy button to solve because you just find out that your network and your competitor networks are now literally in the same room or same building where you're literally just a jumper away. Suddenly, the network engineer doesn't have to go to his boss to resolve a customer complaint about ping time. They can just fix it right there, right? So that should reach the ecosystem aspect is very important. We're bringing it's like having airport in the city that never had one. Yeah.
My point, I think, for what Brent was asking in regards to what does this mean without, right? I focused on what does this mean with, which is jobs, right? Creation, dormant opportunities that have been sleeping this whole time that now have an ability to perform and bring tertiary markets, right, to a tier one overnight, essentially, thanks to, right, the envision and knowledge that Hunter and team have been able to bring to this is tremendous. It's a sleeping giant, right? There's going to be a change, as you're starting to see already, where these large-scale data centers are starting to hit their mark, or miss their mark, substantially, not by a little bit, but by a substantial amount. And with these IXPs that are going up, the surrounding areas, right, the rings of latencies, I like what Hunter would say with that, is opens up the dormant opportunities, which is jobs creation, taxes, everything else.
So we're in a new age. I refer to this as the infernet, not the internet. It's physically different. The geographical concept is taking a bit out to the global public routing table as the internet, bringing the data workload on the GPUs to a city for it to be run there, touch the core router and go to the endpoint at the lowest possible latency. That's the infernet. And then creating a fabric that connects those nodes. Who does that and how it's done? You could look at the NVIDIA Zayo announcement. They're buying terabits, okay, of lit capacity. I say no more. Bryan works very closely with NVIDIA. I will say no more. Yeah, so the offtake, what he brings in from the Moonshot Energy perspective, Bryan, represents revenue to that local ISP in the form of multiple 400 gig ports. To start. The best, highest margin revenue they will ever gather will come from the city that they're the incumbent in. No hops, no handoffs, right there. And it's like, it's Christmas every single day. And then we're buying waves on Nexus side to connect the exchanges, the layer 2 switches themselves, which is a little different, but that's to seed a market like Wichita with ASs from remotely to bring them in, like Dallas and Kansas City. We're bringing the ASs to Wichita to start. It starts the flywheel. And then obviously some of you may or may not know, Wichita is an industry town. It's an aviation and aerospace engineering town. And Wichita State University, the campus, is like a city itself. You got Boeing and Airbus and Dassault and Spirit and Textron, and they own Beechcraft and Cessna, and they're all based there on the campus. That's what a lot of these conduits are for too. We don't think of it just as carriers, we think of them all as network operators. They will all have their own fiber cables and fiber panels with their names behind the glass, and that's truly the shopping mall, airport, economic development ecosystem we're creating.
Well, our time has expired. Fascinating conversation as always with you guys. There may be a lot of topics that were discussed during the session today that maybe you've never really thought about before. Come talk to us. All four of us would love to have a conversation around network interconnection and latency reduction and physical infrastructure. And if your communities are not thinking about those things, if your network operators in your community are not thinking about these things, let's have a conversation. 135 cities is where we want to go. We're starting with Wichita. We're gonna expand from there. Thank you all very much for your time and interest in this session. And yeah, please come see us.
A question or two, maybe?
I think.
Okay, we gotta go.
I think we've got to wrap it, unfortunately.
All right,
Thank
we're
you all
available.
very much.
Thanks, Jeff. Thanks, Brent. Thanks, everybody.